All right, perfect. So, like as I was saying, I've used a lot of softwares over the years, and both architectural and structural design softwares. For structural design softwares, I've used the first software I started with was Start Pro. I don't know if any of you know about Start Pro. Start Pro is a very comprehensive structural design software, all right, but it's not mostly popular in this part of the world, all right. So I started with Start Pro, and then proceeded to using ETABS, and then I used ETABS for some time, and then majorly Start Pro and ETABS before I started using Orion. I know most of us might know Orion if you have been um, into this design thing. Orion is actually one of the first software design software that became very popular in Nigeria and this part of the world. All right. So I used around 2019, 20, and I think 21. I used it for a long time. And then before I discovered Protastructure. All right. Now, Protastructure basically is just an advanced form of Orion. All right. Orion and Protastructure are mostly the same. But Protastructure is more advanced in the sense that it can do more number of stories and the other features that were also implemented in the software. Most of us might also know Quick Civil series, right? Quick or Civil Soft, Quick Civil series or Civil Soft. That is also very much popular in this part of the world. It was developed by a Nigerian that is living in UK, right? And it's quite popular, but then it has a lot of disadvantages compared to Orion and Protastructure in the sense that it is not as much robust as these other modern softwares are. All right, so this is just a basic overview of all the softwares that um, are popular in structural design. All right. Now, when you come to architectural design, there are a lot of softwares in that area as well. All right. We have AutoCAD, which is a very, very fundamental software. Right. In fact, I usually encourage everybody that is into the construction field to have ample knowledge of AutoCAD. It's very important. Because most of the drawings that are used um, in construction, either they are done with AutoCAD or they pass through AutoCAD. If you do, you can do a design with Revit and then edit in AutoCAD, or you can do a structural design in Protastructure and do your detailing in AutoCAD. So AutoCAD cuts across most software. So it is very important that you have knowledge of AutoCAD. So AutoCAD is just one. However, apart from AutoCAD, we also have, of course, Revit, which is what we are using for this bootcamp. And then you have other software. You have ArchiCAD. ArchiCAD and Revit are basically almost the same. In fact, they are direct competitors. Interface, not the same interface, but then the same functionalities. They are called building information modeling software. They are mostly used for modeling. All right. Now, apart from this modeling software, okay, other softwares that can be used for modeling include SketchUp as well. SketchUp is a very popular software, but not as robust as Revit. You must have heard about SketchUp. All right. So apart from this, you also have what we call rendering software. They are also classified under the architectural design category, but then they do more of rendering. You can see, you must have seen architectural designs, how beautiful they are, the photorealistic images of your architectural design. These are usually done with rendering softwares. And examples of these rendering softwares include we have Lumion. Lumion is a very powerful software for rendering. And then you have V-Ray, which is also a very powerful software. And then you have others. You have Atlantis, you have Blender, you have 3ds Max. There are a lot of them. All right. Now, these rendering softwares basically are heavy software that don't usually work on average computers. All right. So I think to work with Lumion, you need a system capacity of above 8 GB RAM. All right. But if you have less than that, Lumion might not work properly. But V-Ray, I think V-Ray can work in a 4 GB RAM laptop, but then it might not be very, very fast. So these are just basic overview. I believe we have a good number of persons in the class now, so we can start with what we have for today. All right. So now, if for those of us that are into construction, you would agree with me that before the commencement of any construction, of any building construction, there are four major drawings that are necessary. All right. After the surveyor must have done the land survey and all that, the next thing that is required to be done for a construction to start is to make an architectural drawing based on the survey plan that has been produced by the surveyor. All right. So for those of us that are beginners, a survey plan simply signifies a plan showing the boundaries of the land. All right, whether it is 2 plots of land, 3 plots of land, 1 plot of land, or however, and the dimensions of the land. Now, based on that drawing, the architect or whoever is the architectural designer produces an architectural plan for that particular project, whether it's a residential, commercial, industrial, or a non-building structure. Right? Now, there are standards, of course, that the architect follows, such as what we call setback distances, offsets, and then, of course, basic architectural principles to be able that the architect must follow to be able to produce a perfect architectural drawing. Now, once the architectural drawing has been produced, the next thing that is necessary is for the structural engineer, the person involved in the structural design, to actually determine whether that particular structure that has been designed by the architect is buildable. All right. So that is where structural design comes in. So now get the difference. Architectural design is all about designing the aesthetics of the project, where the bedrooms will be, where the sitting room will be, and all that and all that. Now, that doesn't mean that that design can be built. All right. Now, the structural engineer, the person involved in structural design, is expected to determine whether that structure can withstand the loads that are going to come on it, whether it is buildable, whether it's going to stand the test of time. All right. Now, that's what we call structural design. All right. Now, these are two very important drawings that need to be produced. Now, we also have two more. We have the electrical design and we have the mechanical design. All right. Now, but that's outside the scope of this talk. All right. So now, when those these drawings are produced, of course, the contractor uses it to begin the construction. So basically, in this boot camp, what we are going to be discussing about, or what we are going to be training on, is on these two important drawings, architectural and structural drawings. And like I've explained to you, there are various softwares that you can use for these drawings. And in this boot camp, we're using Revit for architectural design, and we're using Protastructure for structural design. And I've also explained to you why I make use of these particular softwares. From my experience in using all of these softwares, these two softwares are actually easy to learn, and they are very much robust, all right, and comprehensive for you to make anything you want to make. All right. Now, in this particular first session, remember this is an intro class. So I'm going to be discussing with you some basic principles that you have to understand before you eventually even start, you even open yourself to start making any drawing. All right. And also I'm going to show you the interface of the software, how it works, how easy it is to use, so that you'll be able to get conversant with them. And then while the bootcamp starts, we go more into details. All right. Now, let's start with structural design. Now, as the class is going on, if you have any questions, maybe about something I said or something that you didn't understand, you can simply unmute your mic and then ask your question, or you can ask it in the chat section. All right, you can ask it in the chat section. Now, before we start, I would like to understand, I don't know the categories of persons we have in this particular class. All right, whether we have professionals or just beginners. So maybe because of time, I might just pick maybe 3 to 5 persons. You can just unmute your mic, maybe introduce yourself, tell us your name and what you do, whether you're a site engineer or whether you're an architect or you're just in the construction field. Remember, you can be anything in the construction field. all right, to be able to use any of these softwares. So maybe we can just have 3 persons or so. You can just unmute your mic, let us know your name so that I'll be able to understand the categories of persons we have in this class to enable me, yeah,
Hello?
attend to.
Hello?
Yeah, Mr. Gerald.
Good evening.
Okay. My name is Gerald Agbaye, and then I'm a site engineer. Actually, I had a degree in civil engineering. Yes.
All right, perfect. Certain. Yeah, okay. Have you used any of these softwares before?
Probably not much.
Not much. Okay.
Yeah.
Okay. That's good. All right. So you're a beginner in the use of the software. All right.
Yeah,
So
sure.
another person. Another person.
Hello?
Good evening, class.
Yeah, Benjamin.
Yeah, good evening, class. My name is
Yeah.
Benjamin Udo. I am a civil engineer. I work as a site supervisor.
All
I
right.
have a basic knowledge of AutoCAD, and yeah, I was put through on Orion, though I'm not really using it at the moment.
Okay. You're not really using AutoCAD.
No, I'm using AutoCAD. I can use AutoCAD. I make drawings with AutoCAD. Now, I mean the Orion that I have a glance through of Orion. Though I can't really I'm not really using it at the moment.
Okay. Okay.
Yeah, but since you said Protastructure is the same thing as Orion, can you mention something like that?
Yes.
Though a bit advanced than Orion. I think that
Yes.
would be helpful.
That's correct. Okay. So that's fine. I believe with the little knowledge you have in Orion, it would be easier to transition to product structure for you.
Oh,
Okay. So any other person, maybe the
Good
last
evening.
person. All right, Mr. Casey.
Good evening. I am Engineer Kingsley by name.
Okay.
I'm actually a construction engineer.
Okay.
So I actually have what I have in knowledge. I have knowledge of AutoCAD and equally the one I use for my design. I use Adenuga structural design.
Okay.
So that's what I
Okay.
use. But when you started talking of this Revit and when I went through those demo you sent, I discovered that the thing is actually a better package compared to what I have in that distance. So that protest structure, I have actually gone through it, and I discovered it has a lot of things that I couldn't find in that
Yeah.
Adenuga. So I think that would be
Okay.
very
I believe
for
Adenuga
anyone to
is
join
a
me.
Nigerian paid software.
You said?
I said I believe Adenuga is a Nigerian made software.
Yes, it is easy for me to navigate because that one, like when you're designing a slabs and those ones, this thing is just self-explanatory because I went through
Yeah.
the book and this. But in terms of let's
Robustness.
yes, it is not there like that. But I would love to understand this protest structure very well, Sha.
Yeah. Yeah. I think it is same as Quicksilver series. Quicksilver series is also mostly this Nigerian made software. They are usually um what do I put it? They are usually restricted. They are not like Quicksilver series. It is just meant for rectangular buildings only or square buildings. You can't really use it to make asymmetrical shapes, curves, and all those and stuff. Or it will be difficult to use them. All right. So okay, that's good. That's good. So you just have a basic understanding. I believe that would also be beneficial for you in the course of the bootcamp. Okay, because of time, we'll just continue. All right, so like I said earlier, we are going to be starting with product structure, and then I'm going to be sharing with us some basics principles that you need to understand before you actually open the software to even start any design. All right, so let me share my screen, and then so you can see. Sorry. All right. So basically, this is product structure interface. I've already opened it here, so it doesn't waste our time while it is open. So when you install product structure first, I believe my screen is visible. Okay. Okay. So when you open, all right. So when you open product structure first, right? This is what you are going to see. Okay. Here you are going to have some tabs that are not active because you have not actually gone into the software. All right. So we have the building setup tab, the modeling tab, the loading, the review, analysis, design, drawings, and so on and so forth. All right. So now here, if you install product structure newly, you might not have anything here. All right. You can see here I have recent projects. All right. So these are projects I've done recently. All right. So you might just have
The screen
only
is not showing from my end, though.
okay.
Of its network.
You might need to leave and come back.
Oh,
Let's see if that's going to solve the problem. Okay, so when you install product structure newly, you might just have the Revit, sorry, the open project here and the new project. And then over here, you have some news, all right? So whenever product structure has a particular newsletter they share, you might actually see it here, all right? And then here you have some videos on updates, any updates that product structure makes, you are going to see them right here. All right. So basically, this list is going to be scanty when you install it newly. So you have to go to open project to create a project. You have to go to new project rather to create a new project, or you open an existing project if you have one in your system already. All right. So for the sake of this class, I'm going to quickly use this particular project I have.
I cannot hear you again.
It's like maybe he was having a network problem.
Oh, okay. Probably it's not my end only.
I think he has. It's like he has even gone out, safe.
Oh, okay.
Okay, he's back. Yeah.
Sorry. You can still hear me, right?
Yeah, we can hear.
If you can
Yeah, we
hear
can
me,
hear
Yes,
you.
we can hear you.
All right, perfect. And my screen is also visible. Yeah.
Yes.
It is.
All right, perfect. All right, so let's continue. So I just opened before the network disconnected. I just opened a recent project, so we can use this for this class. All right. So now, . All right. So here you have a block of flats, right? And 1, 2, 3, about 2 stories, right? Ground floor plus 2 upper floors, and then it is supported on a wrapped foundation. All right. So the soil where this particular project is weak. All right. So that is why we are using wrapped foundation for this project. We have about 1.2 meter depth of beam, and then we have about 250 depth of slab, wrapped slab. All right. So above we have the floor beams of I think floor beams of 600 depth, and floor slab of 150 depth, and then we have columns of 200 by 450. That is 8 inches breadth. All right. And then over the top we have is a slab roof. All right. So it is not a pitch roof. So we're also using 150 depth of slab for the roof, and then all over here we have some parapet walls and all that. All right. So this is a basic project that was done in Protastructure. All right. Now, like I said, I need to let you know some basic principles that you need to observe before you even start your project. Now, the first thing is that you have to understand that there's what we call building codes, right? Building codes. Different countries actually have different building codes. All right. We have their European code, we have the American code, we have the British code, we have German code, we have the Indian code, and many others. All right. But in this part of the world, in Africa, we mostly use the British code or the European code. All right. The British code is actually more popular. British BS 8110. All right, this is the code that we use for structural design. Now, what is a code? A code is simply a set of guidelines to enable you design structures. All right, design structures. It tells you, okay, these are the kind of moments that should be applied at this particular point. These are the kind of tensions that should be applied. These are the spacings, minimum spacing, maximum spacing that should be observed. These are the ties, the kind of ties or stirrups that you should observe. So basically, it's just a set of guidelines, right? Nothing much. All right. Now, fortunately, some of these softwares, especially Protastructure, have inbuilt codes in them that automatically applies when you are designing a structure. For example, Protastructure actually has, I think, 8 or 10 number of codes that you can use. So let me quickly show you. So let me open a new project so I can show you what I'm talking about. So I'll go to a new project here. All right. So here, if I click on new project, I can enter the project name. Let's say duplex. Sorry. Let's say duplex design. All right. Now I can now select the kind of code I want to use for my structure. This is what I'm talking about. Brazilian code, Hong Kong, Indonesia, Malaysia. So these are the codes available in Protastructure. UK code, which is the British code that we are using, and also Euro code. All right. So you just have to select the code that you wish to use and then click on OK. So whatever you are going to be designing in this particular project interface is going to be applying the guidelines of the British code. All right, this is very important. So you don't necessarily need to know what is contained in the British code, although it is an advantage if you do. You can just search online for BS 8110. You can download the soft copy, maybe to go through it at your own convenient time. It's available online. All right. So, but then what I'm saying is that Protastructure has built in that particular code into the software. So as you are drawing or as you are designing, it applies the code's principle automatically. All right. Now that's the first thing you have to understand. Code, building code. Now, this BS 8110 basically is the general code. All right, general code. We also have codes for if you are designing high-rise structures, you have codes for that. If you are designing water resistance, what structures that should resist other types of loads, you have code for that. If you are designing fire resistant structures, you have code for that. All right. So this one is just the general code that I just stated here. Now the next thing you have to understand is what we call let me just explain this. Okay, first of all, we are talking about structural design, right? Structural design. What is structural design? All right. Like I said, if for any structure to start or for any construction to start, you need first the survey plan, then you need the architectural design, and then you need the structural design. All right, and then we also need the mechanical and electrical as well. So talking about structural design, I don't know if anybody have an idea or just a layman explanation of what structural design is about. When you talk about structural design, what exactly are you talking about? Is there anybody that have an answer? What is structural design? Or what is a structural drawing? Anybody? Just however you want to put it. It doesn't have to be accurate. Nobody has an idea. All right, so let me help us. All right, so basically, all right, structural design is basically about designing a structure in order to resist layman definition, in order to resist the intended loads that are expected to come on it. All right, structural design is about designing a structure in order to resist the intended loads that are expected to come on it. A structure can be a building structure, a non-building structure, whatever structure it is. There are loads that will be applied or that will come on that structure in due course and in the course of time. Take, for example, a building structure. The building that you are living on right now. You as a person, you are acting as a load on that structure. All right. Your furnitures, whatever you have on the structure, are all acting as loads. So the structure is expected to resist every load that is expected to come on the structure in the course of its lifespan. All right, that is what a structural design basically means. Now, if you are designing a structure, you will need to understand that there are basic structural elements that actually carry the loads of the structure, and those are the structural elements that you're actually designing. All right, a structural design is not about designing your furniture or your space or your doors or windows or all this stuff. Now, what you are designing is the structural element of that structure. All right. Now, what are the structural elements of a structure or elements that are expected to carry the loads of a structure? First, you have your foundation. All right. You have your foundation. Then you have what? Your columns. All right. Then you have your beams. All right. And then you have your slabs, basically. Then if you want to add others, you can add your staircase. It's also a structural member. All right. So these basic 5 elements that I just put here are the basic elements of the structure. All right. These are elements that are expected to take loads that are expected to come on the structure in the course of its lifespan. All right. So when you talk about structural design, you are designing the foundation, you are designing the columns, you are designing the beams, you are designing the slabs, you are designing the staircase, basically. Now, of course, you can have other things. Take, for example, your lift shaft. If you have, if it's a high riser, your retaining walls, if maybe it is an underground building and you should have retaining walls, and then maybe your culvert that is expected to be maybe in the front of the building between the road, all right, or you can call it your drainage, and then other elements as well. So these are all elements that you should design depending on the kind of structure you are designing. But basically for a residential building, these are the 5 structural members. All right, foundation, columns, beams, and slabs, and then staircase. Now let's talk about this one after the other. All right, remember we're talking about basic principles that you should understand before you go into designing. Now, talking about foundation, all right, there are different types of foundations. Like I showed you in the project that I did recently. Mr. Hillary, you have a question. I don't know if you are raising up your hand or that is a mistake. Is it a question, Mr. Hillary? I don't know if you are still around. Okay, let's continue. All right, so now, like I showed you in the project that I did, 2-story or 3-story building rather, on raft foundation. So raft foundation is just one example of, sorry, it's just one example of a foundation type. All right. So under the foundation category, we'll have raft foundation, like I showed you. Then we'll have the pad foundation, which is the one that is mostly popular. All right. We'll have the pad foundation. We'll have the pile foundation. All right. We'll have the strip foundation. All right. So these are basic types of foundation that you have to understand. Now, when and where do you use these types of foundation? The normal foundation type that we know is the pad. That is the one that is rectangular in shape, and you just have maybe a 1 meter by 1 meter excavation, and then you have your reinforcement mat, and then your concrete, maybe 300 mm depth, maybe 1 meter by 1 meter, or 1.2 meter by 1.2 meter. So these are examples of pad foundation. We also call them isolated foundation. All right, they are isolated foundations. Now, these foundations are basically used for structures that are expected to be built on a stable soil. All right, a stable soil. When you have a stable soil and you don't have much load on the structure, so you can use pad foundation for that type of structure. All right. If you have a question, you can simply unmute your mic and just speak. So you can simply unmute your mic and just speak. All right. So
Hello.
all right, good. Continue.
Please, I just want to know, please. This, can we have the record of this particular this thing when you're done?
Yes.
Because the network, as it is, the network is actually fluctuating. So at times, maybe as you're teaching, the network might, because I just observed that I had a network issue. I had to reconnect again.
Okay. Okay, no problem. I'll see how I can send the recording as well. Yes. I'll send the recordings after the class.
Okay, no problem. Let's continue.
It's okay. All right. So we're talking about foundations. Now, like I explained, pad or isolated foundations are foundations that are common and are usually used for structures that are not expected to take much load and are expected to be on stable soil. All right, are expected to be on stable soil. Now, we also have the raft foundation. All right, the raft foundation, which is the one I showed you. Now, raft foundations are basically used for structures that are expected to be built on soils that are not that strong, muddy soils that have the water table at a very high depth, all right? And then soils that generally are not strong, all right? So now the principle behind this is, let me quickly show us something. Open project. Let me open that block of flats I have here. All right, so raft foundation, the principle behind it basically is load distribution. No, okay. Now, for a normal part foundation, all right, a normal part foundation has the footings below each column, right? You must know what I'm talking about if you are into construction, right? Maybe 1 meter by 1 meter by 300 mm below each of the columns, all right? So the loads come all the way from the roof down to the roof beams, down to the columns, and then down to the other beams here. I'm going to explain this load distribution soon, all right? But then just understand that the loads come from above and then comes all the way to the foundation. So each part is taking the loads coming from each of the columns, all right? Each part is taking the loads coming from each of the columns. Now, because the soil is stable, all right, because the soil is stable, it is not going to affect the structure because all the loads are all coming individually on the part, and the soil is stable, so it's taking them individually. All right. Now, for the sake of a raft where the soil is not okay or the soil is not so strong, the soil bearing capacity is not high. All right. If you use part foundation for such kind of structures, what you are going to experience is what we call differential settlement. Each column, because the load from this column is not the same as the load from this column. So this column is going to be deflecting more than this column. All right. This one might be deflecting more than another column. So you have differential. So this column that is having more load will be deflecting more. All right. Why this one is not going to be deflecting more? So you are going to have instability or instability in the entire structure, and can eventually cause collapse. Now, why do we use raft? You can see here the loads come from the columns, gets distributed to the raft slab. Can you see the raft slab here? The raft slab are reinforced, all right? So the load gets distributed to the raft slab and then to the raft beams. So all the columns are no longer acting individually. They are now acting as a single unit. So what it means is that the entire area of this building is what is carrying the entire load and not individually. Individual columns are not carrying individual loads. Rather, the entire structure is carrying the entire load because the loads are distributed in equally to the roof beams, to the raft beams, and then to the foundation. All right. So this is the basic principle behind the use of raft. If you want the entire unit to act as a single unit, all right, to avoid the differential settlement that we're talking about. All right. So now let's go further. We also have the pile foundation that we have here. I don't know. I don't have a structure that is on pile right here, but I'm going to explain what that means. A pile foundation. If you have not seen a pile foundation before, a pile is simply a long column. All right. If you want to define it in the layman way. All right. So what happens is that instead of rectangular parts or instead of raft beams and raft slab, what we have is that we are going to have a long column coming from the ground level into the ground. Now, we use pile foundations in situations where the soil is weak at the top, all right, and then it is strong at some point beneath the ground, all right. I'm just using layman terms so that you can understand what I mean. Now, this is the ground level. Let's assume this is the ground level. All right. Now, if you go 1 meter below the ground level, you might have weak soil. You go 2 meters below the ground level, you also have weak soil. 3 meters, 4 meters, you have weak soil. Now, as you go deeper, the soil is going to become stronger. All right. So you might find out a strong soil 10 meters below the ground or 15 meters below the ground, as the case may be. So the principle behind pile foundation is to take the load from the column all the way down to where you have some stability below the ground level. All right, that is basically how pile works. All right. Now, apart from the fact that the pile takes the load all the way down to where you have some stability, there's also what we call friction resistance. If you have a column below a pile below the ground, all right. So let me explain what I mean. If you have a pile below the ground and you have some soil surrounding it, once the load is coming from the column, there's going to be friction between the pile itself and the surrounding soil. So that frictional resistance is also part of what is taking the load from the column, as well as the end point of the pile, which is also eventually taking the load from the column. So you have two column bearing capacities, two pile bearing load bearing capacities. You have the end point bearing capacity, and you also have the friction bearing capacity. All right. So let me not go much details into this. All right, so just understand that piles are long columns that are dug deep into the ground to take care of the loads coming from the columns all the way down to where you have some soil stability. Okay, so now we also have the strip foundation. The strip foundation is also quite popular. Strip foundation is basically a combination of pad and tie beams. All right, so in cases where you want to use a pad foundation, but then you don't want a differential, maybe RAF's foundation is expensive to do for you, all right, but the soil is not stable, hence you cannot use only pad foundation. So what we do is simply to have a combination of pad and tie beams. All right, remember the principle. The principle is to make the structure act as a single unit when you have a bad soil. All right, so you can just use a pad foundation and then tie them up with beams. When you tie them up with beams, what's going to happen is that the loads are going to come from the columns down to those beams and then down to the pad. So in a way, the structure is still acting as a single unit. All right, it's still acting as a single unit. So in the course of this bootcamp, I'm going to be sharing with us why exactly and where and how to use these several types of foundations based on the cell bearing capacities of your land. All right. So we've talked about pad, we've talked about foundations rather. Now let's go over to columns. All right. Now there are three types of columns. All right. Remember, if you have a question, you can simply unmute and ask the question. We have what we call axial columns.
Hello, let me just ask one question before we move down to that column axis.
All right, go ahead.
There's actually a project we are working on now, and we are constructing what we call a BVS. It's called a block valve station.
Okay.
It's called a block valve station, BVS. Usually, it's a kind of it's a structure where we have a control for gas stations.
Okay.
So now we discover that in most of the areas we are actually constructing this particular BVS, this block valve station, we discover that some of the soils over there are not really stable.
All right.
So we decided to introduce, because like this thing you're talking about, I want to know if actually this one we are looking at is a kind of strip foundation in a way, because we're actually combining the pad foundation with a ground beam.
All right.
Yes, we actually combine the pad foundation with the ground beam. The ground beam height is just 1 meter.
1 meter, okay.
Yes, we run it round
the entire columns.
Yes, round the entire place area. We just run it round like in a right angle. run
Yeah.
round. Then we have columns all over.
Yes.
Yes. So
Yes.
that one you can also categorize that one as a ground
Yes.
strip foundation.
It's a strip foundation. Yeah.
Okay,
It's
that's
a
good. That's
strip
what I just
foundation.
wanted to understand.
Exactly. So the
Right.
loads come all the way up, distributed to the ground beams and then down to the pad. So
Okay,
it
that's
makes
good.
the entire unit act as one.
Yeah, that's good. All right.
Okay, good. So now coming over to columns, we have basically three types of columns: axial columns, uniaxial columns, biaxial columns. All right. Now let's briefly explain this one after the other. So axial columns, basically, if you look at this plan, let's go to the plan view. If you look at this plan, you will discover that, okay, before I explain this, let me first of all explain load distribution. All right. Now, if you look at this plan, you will discover that we have these lines here. You can see this lines that looks like X. You can see this one that looks like that is in this shape. You can see this one that is in this shape. These are called yield lines. All right. These yield lines tell us how the loads are being distributed from the slab to the beams. So now for this particular slab, if you look at this one, what this is telling us is that the load of this triangular part of the slab is going to this beam. The load of this triangular part of the slab is going to this beam. The load of this triangular part of the slab is going to this beam. This one is going to this beam. Now, if you look at this one, the load of this triangular part is going to this beam. The load of this trapezoidal part, you can see this it's not a triangle, it is a trapezoid. So it is going to this beam. This one is going to this beam. So this one is going to. So all the slab have yield lines. All right. Now, how do you understand these yield lines? How you understand it is that if load is applied on this structure, on this slab right now, failure is going to start from the center. All right. So you are going to be seeing cracks on the center, and then the crack is going to proceed from the center at this angle to this column, at this angle to this column, at this angle. If you have seen a proper slab failure, this is how it happens, right? The crack begins from the center and proceeds to the edges. All right. So for this one, the crack begins from the center, proceeds left and right in the left and right direction, and then at a point it starts proceeding to the edges. All right. Now, this is what that means. Okay, let's talk about this one. You can see this one. This one starts from the center, proceeds up and down, and then at a point it starts proceeding to the edges of the slab. So this is how a slab fails. Now, to counter that failure, we design the beam such that it's able to resist the load coming from this part and coming from this part. That is this particular one. While this one is able to resist the load coming from this part and coming from this part. So it's a very complex process. This beam takes care of this load coming from this trapezoidal part of the slab and this trapezoidal part of the slab. So all the slabs are distributed down to the beams in this manner. All right. Now, when the loads are distributed to the beams, they are divided into two. You can see the beams are supported by two columns each. All right. So the load coming from the slab is joined together with the self weight of the beam, and it is shared into two. Half of it goes to this column, half of it goes to this column. All right. So what that means is that this column is carrying the load of this trapezoidal slab or triangular slab and half of this beam, and then it is going to the column. So as the load comes to the column, it transfers all the way down to the foundation. Now let's go to 3D view. So when those loads are transferred from the roof slab to the beams, they come to the columns, right? Likewise, on the second floor, the same thing happens. The same load distribution happens. So additional load comes to the column, right? On the ground floor, the same thing happens. The load is distributed from the slab down to the ground first floor beams and then down to the column. This explains why loads from the ground floor columns is more compared to loads from the first floor columns. And loads from the first floor columns is more compared to the loads from the upper floor columns, because these ones are just carrying the loads of this one, while this one is carrying the loads of all these ones plus this one. This one is carrying the load of all the ones at the top plus this one. All right. Now those loads are distributed to the columns and then down to the foundation. So this is how columns. This is how load is distributed in a structure. Now, based on the loads that come to the columns, we have the different types of columns. All right. If you look at all the columns, you will discover that this particular column is carrying the load from this, from this, from this, from this, from this, from this as well. So it is a kind of balance load or balance loading. All right. So this particular column that is at the center are referred to as axial columns because they are only subjected to compression load coming from the beams on all the four sides. All right. They are called axial columns. So axial columns are usually center columns, columns that are at the center of the building because the loads on them are only compression in nature. All right. Now, we also have uniaxial columns. If you look at this column at the edge, you will discover that it is carrying the load from this slab, from this one, from this one, from this one. It is only carrying the load on one side. This side is free. There's nothing here. There's no slab here. All right. So when this column is carrying this, tries to carry this load, there's something that is likely to happen. It is likely to bend in one direction because the load is only acting on one direction. All right. So it's just like if you have a straight stuff and apply a load on it, apply a load on one side of the line or of the straight stuff, it is likely to bend in the other direction. I don't know if you understand what I'm trying to explain, right? So as the load is coming on this direction, it is likely to bend in this direction. So this column is going to be experiencing moment in one direction. That is why we call it uniaxial. All right, it is experiencing moment in one direction. Now, how about this particular column? This column doesn't have anything here, and it doesn't have anything here. So this particular column is likely going to experience moment in two directions, and that is why we call it a biaxial column. All right. So these are just fundamental theories that you have to understand. All right. So we have axial columns, uniaxial columns, and we have biaxial columns. Now there's more to this explanation, but I don't necessarily need to go further into details. In the course of a bootcamp, I'm going to take my time and explain most of all these things. All right. So we have three types of columns: axial, uniaxial, and biaxial. Now let's go to beams. All right, let's go to beams. On beams, we have what we call simply supported beams. We also have what we call fixed beams. We also have what we call cantilever beams. All right. Now, let me quickly explain what this means. Right. Simply supported beams are simply beams that are simply supported. That is what that means is that they are just the supports are not fixed. All right, they are just simply supported. Examples of simply supported beams are mostly your steel beams. You know, you can have an I section of a beam that is an I section, and then you have columns, maybe concrete columns or steel columns carrying them. All right, that is an example of a simply supported beam. It is not integrated. They are not integrated. All right, I'm talking about steel beams that is connected by nuts. to the steel columns or to the concrete columns. All right. Both of them are not integrated together. So that's why we call them simply supported. Now, in the case of concrete structures, they are mostly fixed. They are mostly they mostly fall under the fixed category because the concrete beam and the concrete column are acting as a unit. They are integrated. So we call them fixed beams. All right. So if you are designing a concrete structure, everything you are doing are fixed beams. There is no simply supported beam in a concrete structure. All right. Now we also have the cantilever beams. All right. The cantilever beams, of course, you might know, cantilever beams are simply beams that don't have any support on one end. Take, for example, this one. All right. You can see this beam is coming all the way from inside, and then it is overhanging here. There is no support at this end. So this is an example of a cantilever beam. All right. This is an example of a cantilever beam. Now let's quickly go further. So that we can be able to. Okay, so we have slabs. All right. Under slabs, we have what we call, they are usually categorized basically into two. One-way slab and two-way slab. All right. One-way slab basically are slabs that have this yield line pattern. Let me just show you. These are examples of one-way slab. The slab that have this pattern and this pattern, and then two-way slabs are slabs that have this pattern. Now, how you can determine one-way slab and two-way slab is simply based on the length and the breadth of the slab. All right. So if the length of the slab, there's how you, okay. Is it visible now? The cursor. Is the cursor visible? If you can see my cursor, can you indicate?
Hello, I'm not seeing that your cursor. Put it, let's see what you're trying to.
Okay, this is where the cursor is right now. I don't know if it's visible.
Yes, yes, yes.
Okay, it's visible now. Okay,
It
good.
is visible.
Okay.
Yes,
Okay.
this is what I see now.
So we have, like I said, we're talking about slabs now. Like I said, slabs are basically divided into two: the one-way slab and the two-way slab. So I said slabs that have this type of yield lines are what we term as one-way slab. And the slabs that have this type of yield line that is just a kind of star shape are what we call the two-way slab. Now, how you can determine one-way slab and two-way slab, apart from using the yield line, is based on the length and the breadth of the slab. All right. If the length, there's a formula we use to determine one-way slab or two-way slab. That formula is if the length divided by the breadth is greater than 2, it is called a one-way slab. While if the length divided by the breadth is less than or equal to 2, you can call it a two-way. All right, so let's get practical with that. So if you look at this slab, let's check the dimension. So I'll just go to dimension. Let's see the dimension of this slab. This is 4613 in length. And what is the breadth? Let's see the breadth. The breadth is 2850. So 4613 and what? 2850, right? So when you divide this, the system is quite slow. So the length divided by the breadth, if it's less than 2, it is going to give you a one-way slab. If it is more than 2, rather, it's going to give you a one-way slab. If it is less than 2, it's going to give you a two-way slab. Now, this is not how do I put it? It's not basically you when you see the yield lines here, you would confirm that whether it's a one-way slab or a two-way slab. You can see some of them, they are almost one way, but they are not exactly one way. If you look at this one now, you can see it is almost a two-way slab because the line here is very thin. All right, why these ones are mostly one way. This is a typical example of a one way. Let's check the dimensions of this one. Let's see. Measure. This is 5150, and let's see the breadth. Let's see the breadth. 1150. So when you divide my calculator, so we have 5150 and 1150. So 150 divided by 1150, it gave us about 4 point something. So it is more than 2. That makes it a one-way slab. Let's look for a typical example of a two-way slab. This one is a typical example of a two-way slab. Let's check the dimension. The length here is 4825, and the breadth here is 4613. All right, 4613. So when you divide 4825 divided by 4613, it's going to be given 1 point. So it's less than 2. So it is a one-way, is a two-way slab rather. All right. So this basically are examples of a slab. All right. So now we have a staircase. Under staircase, you have what we call the dog leg staircase. All right. We have the open newer staircase. We have a lot of them. We have the spiral staircase. All right. What else? We have the cantilever staircase. All right. We have dog leg open newer. We have a lot of them. A lot of them. So let's quickly explain some of them. So basically, in most of your structures, you use you have what the dog leg staircase. The dog leg staircase is simply the normal staircase we have. So if you go to Google, let me just show you how it looks. Dog leg staircase. All right. So your normal staircase is dog leg. Let me open plan. Let me see. Okay, this is a typical example. You can see this staircase. You have a flight, you have one flight, and then you have a landing, and then you have the second flight going to the first floor. All right. So this is the section. So this is an example of a dog leg staircase. All right, which is mostly what we use in normal buildings. Now the open nowhere staircase. Let me show you a picture of it. Or open well staircase. I'll call it open well or open well. This is a typical example. Let's open this one. Or let's open this one. Okay. So where you have 3 flights, you must have seen staircases that have 3 flights. You have a flight, the first flight coming to the landing, and then you have another flight at the right angle, and then you have another landing, and then you have a third flight now going to the first floor. All right, this is an example of an open well staircase or an open well staircase. All right, so these ones are mostly used in commercial buildings, maybe your malls, your supermarkets, or what have you, where you have a number of persons that are going to be using the staircase. All right, so we also have the spiral staircase. That one is self-explanatory. That is in the form of a spiral form. You can see this staircase here. This is an example of a spiral staircase. All right, it is going in a spiral form up to the first floor. Then you also have the cantilever staircase. Let me show us an example. All right, so you can see this. This is a typical example. It doesn't have support per se. All right. Is somebody asking a question? Okay. Okay, let's continue. So this is an example of a cantilevered staircase. All right. It doesn't have support, but it doesn't have any walls attached or any beams. It is just in the cantilevered shape. Mostly, they are mostly held by a single beam at the center. Sometimes you can see they can be in this shape. And what that means is that this beam is at the edge and the staircase is cantilevering out of the beam. You can see it here. All right. In other situations, the beam can be at the center of the staircase, and then you have the steps on the beam. Right. This is also an example of a cantilevered staircase. All right. So this is just basic examples that I'm giving to us. All right. Now, if you have other structural elements in your structure, you can also design them. Take, for example, your lift shaft, your retaining wall, your culvert. I might not go into details on this in this class because of our time, so that we also have time for questions and all that. Okay. So in the course of the bootcamp, we are going to go into details in actually understanding these principles and then using them in Protastructure to make our designs. All right. Now, the last thing that I would like us to do in Protastructure before we move over to Revit is to see how the interface works. All right, the interface of Protastructure. So I'm just going to go to create a new project, and I'm going to call it first class intro project. All right, I want to create a new project, so I'm going to type the project name and then click on UK code and then select OK. All right, so this interface is going to open up. So I just want to quickly show us the interface. All right, so in the interface here, basically the interface is basically divided into 4 sections. 4 sections. Under the first section is called the menu section. You have under the menu section, you have the building setup tab, you have the modeling tab, you have the loading tab, the review tab, the analysis, the design, the drawings and reports, CIM, and display views and help. Right under each tab, you have commands or tools. Under the building setup tab, you have the open, you have the merge building models, you have IFC import. This is where you want to import your structure from another software. All right, you can import it using this IFC, or if you want to import from AutoCAD, let's say you have your architectural plan in AutoCAD and you want to import it directly into Protastructure, you can use this DSF import here. If you have your architectural plan in Revit, you can import from Revit directly into Protastructure. All right. You have the external reference there. You have materials. You have settings. These you can change some settings that are suitable for you. You have your load library. All right. And then you have your stories. Because of time, I would have explained this load because loading is very important. But let me leave that for now. Okay. So after the building setup tab, we'll have the modeling tab. All right, under the modeling tab, this is the orthogonal axis generator. This is where you can model your drawing directly in Protastructure instead of importing from AutoCAD or importing from Revit or importing from any other software. You can actually model the structure in Protastructure itself using the orthogonal axis generator. All right. Now you have your drawing tools here. Then you have your columns, walls, beams, slabs, rib slabs. I don't know if anybody have an idea of what a rib slab is. Do you know what a rib? Of course, you know a column, you know a wall, you know a beam, you know a slab. Do you know what is a rib slab? Does any person have any idea of what a rib slab is? Rib slab. Any idea? Okay. Okay. So let's don't worry, in the course of the training, I'm going to really start from scratch so that you understand a lot of things. A roof slab is simply a slab that is integrated with beams. If you can even see it from the diagram. A slab is flat, all right? A flat rectangular surface. While a roof slab has a flat surface with beams attached in both directions. All right, that is an example of a rib slab. So we have the slab strip. This is what we use to bring out the reinforcement of our slabs. And then the slab openings. Let's say you have a void in your slab and you want to open it up. You can open your slab with this particular icon. Then you have other stuff here. You have support types, team members, and all this. So let me not go into details. So you have loading. Loading is very important. Like I said, structural design is about designing a structure to resist the intended loads to come on it. So loading is very important. In the course of a bootcamp, I will take my time to explain loading. We have different types of dead load. We have different types of loads. We have the dead load, we have the life load, we have the wind load, we have the earthquake load, we have the snow load, we have the hydraulic load. There are a lot of them, depending on the structure that you are designing. So, and then you have to design based on the highest load combination. There's what we call load combination as well. So I'm also going to explain that in details because of the training. All right. So there are different load combinations that you should apply on the structure, and you should ask for that structure to use the maximum load case to design. All right. So that is by the way. Now you have review tab. This is where you check your building model. This is where you see the design status. This is where you interrogate the design. So you can do a lot of things on this review part. All right. Now you have the analysis tab. This is where you run the analysis. All right. Now, very importantly, there's something I also have to explain in the course of the bootcamp about the analysis. All right. You can see here we have concrete grades and we have steel grades. I don't know if we understand what concrete grades and steel grades are all about. You sometimes you might hear, okay, if you are on site, let me just use the layman terms. On site, you might be using 1 bag of cement. For 1 bag of cement, you might use 4 head-pounds of sand or 7 head-pounds of granite, or 5 head-pounds of sand and 8 head-pounds of granite. Now, what you are simply doing is that you are determining the grade of concrete based on the concrete mixture. If you use 3 head-pounds of sand and 5 head-pounds of granite for 1 bag of cement, it is going to give you a different concrete grade compared to other mixtures. All right. So that is just a layman explanation. So we have the concrete grade. So there's something that you need to understand when using concrete grades. All right. So I'm going to explain that as well. Now, likewise, you have the steel grades. You have the tiger rods, right? What we normally use in, I think in Nigeria and Ghana as well, we use the tiger rods, or you call them TMT. All right. Now, this type of rods are HYSD, high yield strength deformed bars, and that is what we use in Protastructure as well. All right. However, there are other grades of steel that can be used as well, but we normally use the grade 410, which is the tiger rods. All right. Now, if you want to edit these materials, you don't want to use this one, so you can simply are we still together? If you can still hear me, can you indicate?
I can hear you.
All right, perfect. Okay, so let's continue. So I intended using 1 hour for product structure. It's already 1 hour plus. So let's quickly round up on product structure before we move over to what we have on Revit. All right, um, so this is how you run your analysis in product structure, and then you can see the design status and all that. All right, so I think we're going to end product structure here. So I don't know if there are questions regarding this section, so that we quickly attend to that. In the course of the bootcamp, we are going to be, first of all, explaining in details, maybe in the first class, some principles, and then we would be working on 2 projects in product structure. We're going to be working on a duplex design on pad foundation, and then secondly, we are going to be working on a commercial building project on raft foundation and on pile foundation. So we are going to be using the same projects for the 2 types of foundation, so we can be able to understand how to do both of them. And of course, we are going to apply wind load to the high riser structure. All right. So like I was talking about loading, we have different types of load: dead load, life load, wind load. So if your structure is above 10 meters in height, then you have to apply wind load. And so we are going to work on them. We are going to work on them in the course of the training. So it's going to be kickstarting next week. It's going to be kickstarting next week, Monday for Revit, and next week, Tuesday for Protastructure. 3 weeks each. So Revit is going to be running Mondays, Wednesdays, and Fridays, while Protastructure is going to be running Tuesdays, Thursdays, and Saturdays. All right. So I'm going to send further details on WhatsApp. All right. So if there are no questions on this Protastructure, let's move over to Revit. So basically, like I said initially, Revit is an architectural design software. All right. So it is used to draw your floor plans, your elevations, your sections, your roof plans, your 3D modeling, and all the things that are associated with architectural designs. So when you open Revit first, for the first time, we are going to this place is going to be empty. So here I have recent projects. I have the voice quarter design here. I have one project here, and I have septic tank. All right. So here you are going to see these icons: open new, construction template, architectural template, social template, mechanical template. So you have to use the architectural template, all right, to open your project. Now, Revit actually has the functionality of doing structural designs. That is why we have structural templates here. All right. But the structural part of Revit is actually not as robust as as Protastructure. All right. So Revit actually has that functionality to actually design to do structural designs for you. But then I don't really like using it. Yeah. So when you open Revit for the first time, this is what you're going to see. So you're going to see the 4 icons here, signifying the east, west, north, and south elevations. All right. How to design roof span. What do you mean by how to design roof span? Is it a steel structure? If it's a steel roof, Protastructure does not design steel roof. So sorry. So like as I was saying, I'm going to show us how we can. Okay, okay, steel roof. And that's what I'm saying. Protastructure actually doesn't do steel designs. All right. So So I think MTN is still having this issue they're having. I don't understand. So I just switched over to Airtel network. Let me see.
Okay.
You can
So
still
which
hear
where are
me.
you? Are you in Nigeria?
Yes, I'm in Ibadan precisely.
Okay. No problem.
I'm in Ibadan. I believe this Airtel will be better. Okay. So I was asking a question about steel. So I was saying that we can study how to apply the load of your steel roof on your concrete structure. All right. But to design the steel members, Protastructure does not have that capability. I don't know if I've answered the question. Mr. Henry,
I don't
Mr.
think
Henry, are you still there? Okay, good. All right. So let's proceed. Let's proceed. So we are working on Revit now. So newly, this is what you are going to find. All right. So here you are going to have it is mostly divided into 5 sections. Yeah, the Revit interface. You have the menu section, just like product structure. You also have you also have let me add this. Okay, sorry. I'm sharing my screen now. Let me see. Is my screen visible?
no,
I don't. Okay, I don't know if my
no,
screen is visible.
it's not.
Not visible. Okay. Okay. Let me what is it really? Let me see. Um, what is happening to my screen? Um, I'm not allowed to share my screen. I don't. Uh, it seems I can't share my screen anymore. What is the issue? Um. Okay. Is my screen visible now?
Yes.
Very much visible.
Okay. Good. Okay. 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 So let's continue. So we're working on Revit, right? So Revit basically is the interface is into 5 sections. You have the menu section here, just like product structure. We also have the tabs, all right? The architecture tab, the structure tab. Like I mentioned, Revit has the functionality of designing structural design. So that is where you have here. You also have the systems tab. It has the capacity to design electrical and mechanical structures. Electrical and mechanical designs, rather. All right. So you can design your how your mechanical equipment should be, your HVAC, your other mechanical equipment. It also has the electrical parts. You can see these are your pipings, your wire layouts, your cable tray, conduit, electrical equipment. You can actually do this with Revit. All right. Then we have the insert tab here. They annotate for the dimensions and the tests. Right. We have the analyze tab. If you are doing a comprehensive MEP drawing, MEP simply means mechanical, electrical, and plumbing drawings. All right. So if you are doing a comprehensive MEP drawing, you can actually model the spaces, calculate the loads. That is to say, the electrical loads. All right, or the electrical requirements of your structure. All right. So you can actually calculate the load from the lightings, from the AC, from the whatever electrical equipment that's going to be used in the building. So you can actually determine the loading, electrical load of the structure from here. All right. Massing and site. This is where you can actually model irregular shapes. Take for example, you have those kind of funny shapes. I don't know if you have seen Burj Khalifa, the one of the I don't think it's still the tallest structure on earth. Burj Khalifa in Dubai. All right, you can see how asymmetrical the shape is. You can actually do that with it, but it's a very complicated drawing. So you can do that with massing and site here. All right. Then you have the collaborate. Here you can actually collaborate with other architects. Let's say you are working in a design firm and you need to collaborate with other architects or engineers. Mr. Casey, you're asking a question?
Yes. I wasn't seeing your okay. I've seen the screen now.
You're asking a question?
No, you know you were.
Okay. Okay, good. So
Like,
I was talking about collaborate. So you can actually collaborate with other members of the design team.
Say you don't think that if Burj Khalifa has. So I was actually responding to that.
You asked a question. Mr. Henry, Mr. Casey, ask a question. I think his network is lagging. Okay, so let's continue. All right, so that's about collaborate. Now you have the views. All right, so the view tab is actually where you can see the rendered versions of your project, like your 3D model, how it should be. Your sections, you can cut out the sections from this menu. You can call out any part of the structure, any part of the design. Let's say you have a small part of your design that you want to enlarge so that you can see very well. So you can call out parts of your structure from here. All right. So you also have the manage tab. You have the add-ins, you have the modify, and much more. All right. So these are the menu tab. Now over here you have the properties section. When you click on any command on the menu tab, all right, let's say you click on doors or you click on walls, the properties of that particular member is going to appear here. So I just clicked on those and I can find the properties of those. All right, so this is one door. Now, one good thing about Revit is that Revit actually has a library of components, all right, that you can make use of. Take, for example, custom doors, custom windows, custom walls, custom anything, custom tables, chairs, grasses, swimming pool, whatever. Revit has a library of um, of um, of components to make your design actually very good. All right. So in the course of the boot campus, also, I'm going to send us the library of components so that we can be using it for our personal project. All right. So this is about those. Now, under walls, if you click on walls, the properties of the walls are going to appear as well. So this properties section is just a place where you edit the properties of the member that you want to draw. All right. So under walls, you can say I have basic wall here. I have masonry walls. I have partition walls. I have curtain walls, and so on and so forth. All right. That is about walls. All right. We have windows as well. You can find custom windows. You have components. You have columns. You have roof, ceiling, floors, curtain system, railings, round stair, and so on and so forth. Now, over here, you have the project browser. Remember, this is the menu section, properties section, and the project browser section. This project browser section is where you can use to navigate different places in your drawing. For example, here you have the level 1 and level 2. You can create more levels, level 3, level 4. You can rename them to ground floor level, first floor level, second floor level, roof level, and so on. Here you have the ceiling levels. Here you have the elevations, the 4 elevations, east, west, north, and south. And then here you have the quantities. You can schedule your quantities. You have the sheets. You have the families. If you create sections, it is going to also appear here. So you can see the section. So if you want to navigate to any part of your drawing, you want to go from level 1 to level 2, or you want to go to the ceiling level, or you want to go to the elevations or the sections, this is where you go to. All right. Now, finally, at the center here, you have the workspace where you actually make your drawings. So, for example, if I click on walls and let me just draw a random wall here.
Jesus.
All right, this is a random wall. So let me see how the elevation looks like. This is the north elevation of my wall. You can see the level 1 is 10 feet. Currently, it is measuring in feet. So if I wanted to measure in millimeters, I will simply go to manage and then come over here, project units, and then I can change it from feet and inches to millimeters and meters. All right. So when I do that, automatically it is going to change. So 10 feet is about 3 meters. So if I want to make it exactly 3 meters, I can double click and change it to 3 meters. So my first floor level is going to be 3 meters in height. All right. And I can also change this to ground floor level. So I can create more levels for other stories as well. All right. So this is how you can see your elevations. If you create sections, you are going to see them as well. If you want to see the 3D view, you simply go over to views here and click on 3D view. All right. This is it. You can see the 3D view. If you want to see the realistic view, you come over here to visual style and click on realistic. All right. So it is using the default color. This is the default color. So I can change the colors to masonry or brick or stone material, whatever, any color I can make use of in Revit. All right. So Revit is actually very easy to use. It's very easy to use. It's very easy to use. And in the course of a boot camp, we are going to be going step by step. So in Revit as well, we are going to work on 2 projects. We're going to work on a duplex project as well, and then we're going to work on another project. So maybe one project will be having a pitched roof, another project will be having a hidden roof, so that you can see how to actually make use of. Basically, what you have to understand is how to make use of the tools. Once you know how to make use of the tools, you can do anything. You can do anything in Revit. All right? You can do anything in Revit. Let me show us one of just a simple project. Let me open this one up. See? I think this project is still in process. All right? So this is a project. This is just a sample project.
I cannot see
So
the
you can
project.
do basically anything in Revit. All right? You can do basically anything in Revit. So this is a sample project. It's a twin duplex. If you look at it, you can't see it.
Okay.
Is it still visible?
It's not
Is the
visible
screen
yet.
visible?
Not visible yet. I can only see the visibility of the window and the empty interface of the drawing space.
Is any other person seeing the screen?
I can see very visible everything. Everything is
Okay,
visible
maybe
from my side.
for if you are not okay, Mr. Samson Joshua, I think you might log out and log in again to see if you can see the screen.
I will do that.
The slide is visible.
So yeah. So this is just a sample process. So it's a twin duplex. So if you go over to the ground floor level here. So remember, like I said earlier, this under the project browser section is where you can navigate through different parts of your drawing. So you can go to the ground floor from here. You can go to the first floor from here. This is the first floor. This is the compound level. That is the ground floor level. This is the roof level. All right. These are the ceiling levels. These are your 3D views. All right. This is one view. Now these are not rendered. The drawings are not rendered. All right. So when they are rendered, it's going to come out properly. So these are the views. These are the elevations. All right. Let's see. These are the elevations. East elevation. This is north elevation. This is south elevation, and this is west elevation. All right. And then you have okay, I've not created sections yet. So when you create, okay, let me quickly create a section. So I'll go to ground floor level, go to view, go to section. So let me create a section here, and let me create another section horizontally. All right. So when you create a section, you can see that the sections have appeared here. So section 1, see the realistic view, and section 2. This is section 2. All right. So you can see the realistic view, or you can leave it as a hidden line view. All right. So this is just a very simple project. So you can do a lot with Revit. Right? You can do a lot. The components that I was talking about, you can see you have beds, you have I didn't add much components. I think it's only bed and then the sofa in the sitting room and then your WC. All right. So, but then in Revit library, I think I have it on my desktop. Let me show you. London miscellaneous Revit library. All right. So this is the Revit library US metric. So you can see a lot of components. These are doors. These are doors, right? Different types of doors. These are windows, different types of windows. And then you have other things. You have your plumbing materials, you have your furniture, you have a lot of them, electrical components and all whatnot. Okay, so this particular file, I'm going to send it to us in the course of the bootcamp, so we can use it for the project. So we can use it for the project. All right. Now, very importantly as well, Revit also has the functionality of creating videos of your project. Take for example, I want to create a video of this project, how the bedroom looks like, how the kitchen, the living room, and everything looks like. I can actually create a video of the interior of the building and the exterior of the building. All right. I can create it with Revit using this icon here, walkthrough. All right. And then I can render my images and video out. All right. So basically, that is it for Revit. So I don't know if there are questions concerning this.
Yes, I've asked question already, sir.
Okay, let me check. No, we are working on architectural dance. You understand? So electrical and mechanical is another ball game altogether. So majorly architectural. So your floor plans, elevation sections, 3D views, video walkthroughs. I'm going to send the course out. Okay, I've not sent the course outline. So I'll send the course outline to us. The course outline for product structure and for Revit, so that you can see what we are going to cover. I'll send the course outline to us so we see what we're going to cover.
What of if I'm interested in mechanical and not electrical after, sir?
For now, I don't do this. For now, I don't do this. Those drawings.
Okay.
So, any other question before we round up? Before we round up, it's almost 9:50. So, I've already talked about. Okay, Samson, you're asking a question.
No, I'm not asking a question.
Okay. Okay, good. So I've already talked about the duration as well as the time. So Revit is starting on Monday, while Protastructure is starting on Tuesday, 3 weeks each. And of course, the price is already known to us. So you have 1 week, at least from now to next week, from till this weekend, to prepare and to prepare for the commencement of the class. All right. So I'm going to see us in the class. For those of us that would eventually register, we will get started by next week. So, and then additionally, it is always advisable to participate, because there are questions that you might be having that you can ask during the course of the live class. All right, but if you are just depending on the video recordings after the class, it might not. I don't know how that's going to work for you, but then if you have the time, it's advisable to participate, so that as I'm doing what I'm doing in the class, you'll be seeing and asking questions live. So that when you go back to the videos to practice, to just you might not even necessarily need the videos to practice, because I'm going to cover. If you follow the class properly, you are good to go. All right. So if there are no more questions, I think we can call it a night.
All right. Thank you for the teaching. Thank you.
It's all right. You're welcome.
Thank you, ma'am.
All right, thank you.
It's all right. So take care. God bless.